This video shows building the Ox CNC router from Open Builds. I got my kit from SMW 3D. The kit is very complete and well organized. The parts that are pre-cut are done very precisely, although I would recommend following the instructions on YouTube by Mark Carew, which shows the build in the opposite order. If you haven't used T-nuts before and T-extrusion, a bolt and a nut goes through a hole on a part you want to attach to the extrusion. The T-nuts are made to slide into these slots in the extrusion. And now that I've got my corner piece on, I can use it to attach another extrusion at 90 degrees. You use this method basically to fasten anything to the extrusions. Once I've got the corner piece where I want it, all I have to do is tighten down the screws, and everything is held together in an amazingly solid mechanical connection. This is a close-up showing how the T-nut goes into the slot on the extrusions. The extrusions have slots on all four sides like this and holes at the end which can be tapped to attach things there. I'll show you that in a later step. Here I'm putting some of the corner brackets on one extrusion and then fastening these other extrusions to it. And when completed, this will be the base of the frame of the machine. Here I'm putting the T-nuts in the channel, and I can slide the extrusion around wherever I want it to go before tightening up the screws. It's a real nice method of fastening things together. Now I'm squaring up the frame. This is important because anything that you cut with the frame will only be square if the frame is square. So here I'm putting WD-40 on a tool called a tap, and I'm going to cut threads in a couple of these holes. The tap goes in just like a screw would, except you turn a couple times in and back up a half a turn and turn a few times in and back up, and it clears all this metal out of the threads. These corner brackets are used to mount the sides where the trolley moves. A few of the screws didn't have the heads cut out correctly, but my kit included enough spares that this wasn't a problem. These are the wheel kits. You put in a bearing, a washer, the bolt through, and the other bearing, and then usually a spacer of some kind, in this case an eccentric spacer, and the gantry plate and a nylock nut on the other side. Here I'm putting the motor on the gantry plate. It goes in slotted. The screws for it are in slotted holes, so the motor can be moved to tighten the belt. There's a motor on either side. One will run in reverse relative to the other, and this moves the X axis, and that piece of extrusion going across the other way will be the Y. This is the plate that will move on the Y, and two sets of wheels go on top and below, and the other set of wheels in the front will be for the Z, which will move the router up and down. This is one point where assembling in the opposite order would have been more convenient. I've got the extrusion this trolley is riding on, and another extrusion as a brace behind it. And what that's doing, first of all, I have to assemble everything from below, the last set of wheels, and that's difficult. It would have been easier with this off of the main machine frame so I could flip it over. And the other problem is the other extrusion that serves as a brace that's behind this one. It won't really let me access where I have to put the nylock nut, and it's very hard to get at this eccentric spacer, which is not yet in the hole in the gantry plate. This is the problem. This other extrusion is in the way now. And I need to get this eccentric in the hole correctly and then put a nylock on the other side. So here's the view from above. Again, the other extrusion is in my way. And if I had assembled in the opposite order, I might have had other problems. But what I'm doing now is loosening everything up, taking off that other brace extrusion, so now at least I can get at the front. And I'm trying to assemble my wheel kit below. This isn't easy, but it's at least possible with the other brace off. Once I got one wheel kit assembled there, I found it very difficult to get the other set on. Once you do, the frame can move nicely, and here I'm replacing that brace that I took off. For my Z-axis that moves the router up and down, I chose an upgrade to a Nema 23 motor, and for that you get this extra large motor mounting plate, and the spacers will be different. Instead of an 1.5-inch spacer, you stack a 20 millimeter and a 9 millimeter. There's a flexible coupling that goes between the motor and the lead screw. The other axes of the machine are belt driven, so they don't need the flexible coupler. Here the flexible coupler is on the motor. The spacers are in place, and the bolts are now holding the motor on, and the bracket is screwed to the end of the extrusion. Here's the lead screw with a bearing and a locking collar, and the bearing goes in this little hollow in the motor mounting plate. And once I have the bearing seated in there, I'll tighten the locking collar. This is that part of the assembly. Now I'm going to align it with the wheels for the Z-axis and get the threaded rod through the nut, and I use the flexible coupler to move the motor down to the end, so it's easiest to get that plate aligned. Once I've screwed it in, I move the Z up, and I'm installing the plate at the other end, and the bearing and the locking collar. This goes together the same way, except, again, I think this would have been easier if I had started with the Z slide and built in the opposite order. I'm sliding the frame over the side of the table and moving the slide to that end so that I can finally get access and finish. These are the drop-in T-nuts for the belt that moves the Y back and forth on that cross slide, and the instructions say that they'll be too thick to hold to go in and hold the belt. And here I'm proving that this is true. I filed down the nut so it's shorter, and then it goes in very easily, and I just tighten down the screw in order to hold the belt in place. And that's basically the entire mechanical part of the frame. At this point, there's just wiring to do and mounting the router, and then it can cut out parts for the large rig.